everyone, welcome to today's class on physics, specifically on heat. We are still on heat. We are rounding up on heat. On today's class, I will teach us how to find resulting temperature. I will teach us how to find the resulting temperature of a mixture. That is, for example, we mix 2 or 3 substances together, maybe cold or hot or whatever. How to find the resulting temperature of such a mixture. Let's take the question on the board that will take us there. And the question says 200 grams of water at 90 degrees Celsius is mixed with 100 grams of water at 30 degrees Celsius. What is the final temperature? Did I take it again? Let me go again. It says 200 grams of water at 90 degrees Celsius is mixed with 100 grams of water at 30 degrees Celsius. What is the final temperature? The question on the board can be likened to somebody that wants to bathe. Maybe you want to use warm water to bathe. Maybe the person is feeling a kind of cold. So you now boil water and the water reaches 90 degrees Celsius. That is almost the boiling point of water. Now mix it with another water that is colder, which is 30 degrees Celsius. Now the question asks us, after you have mixed the hotter water of 90 degrees Celsius with the colder water of 30 degrees Celsius, what is the mixture? What is the temperature of the mixture? Yes. This is the type of thing we do almost in our different homes. When we want to use hot water to bathe, we boil water. Then we boil water the water will be at a higher temperature. Then we now mix it with a colder water to give us warm water. That's exactly what is happening on the board. Now the question asks us, what is the temperature of the warm water? That is the temperature of the mixture. Let's solve it. Yes. Okay. If you understand this question on the board very well, you will understand that it agrees with the theory of the conservation of energy, which heat is one of them. Heat is a form of energy, which said that energy can never be created nor destroyed, but it can be changed from one form to another. It can be transferred from one body to another. It can also be given from one object to another. Yes. What is happening on the board now is that heat is transferred from hot water to cold water. That is, heat energy is transferred from hot water to cold water. So what actually happened is that hot water at 90 degrees Celsius gave heat to cold water at 30 degrees Celsius, and two of them become a mixture. But the fact there is that the total amount of heat lost by this hot water is the total amount of heat gained by this cold water, which means heat loss is equal to heat gain. I'll write it out like this. Heat lost by hot water. This hot water is equals to what? Heat gained by cold water. Yes. Heat lost by hot water is equals to heat gained by cold water, and two of them become mixture. Okay, let me write out this thing with a formula. You know, physics is all about formula and calculations. So I'll use this formula of thermal heat energy, which says that mc theta for hot water is equals to mc theta for cold water. And if I want to elaborate it, I will say that M stands for mass. So I will say mass of hot water times C stands for specific capacity of water. I'll say that it's C. Times theta stands for temperature change. Let me put the equals to here. Is equals to, come to this M, say mass of cold water. So I'll say I'll write mass of cold water times C is still the specific capacity of water. Two of them are water. So I'll still write it C times theta is still temperature change times temperature change. Okay. Now next thing, I will substitute the values, the information given to us in this question into this. So I will start like this. I will say the first one here is mass of hot water. What is the mass of hot water given to us? They give us 200 grams. If I like, I change it to kilogram. If I don't like, I use it like that. If I'm changing it, I change everything. If I'm leaving it, I leave everything. So I decide to leave everything. I want to use it like that. So I'll write mass of hot water 200 grams. I write here 200. Okay? Put times. That stands here. Now I come to C, which stands for specific capacity of water. Do they give us? No. Now let me say this. Let me just say this quickly. Sometimes they will give us problems that will require us to use specific capacity of water, especially. But they may not give us. Why? They assume that you have it in your head. Yes. So as a student of physics, you need to have this value of the specific capacity of water in your head. Because sometimes on questions like this, they may give you, they may not give you, but you still use it. So from now, know it and memorize it as 4200. So I write times specific capacity of water 4200. You need to know this one offhand. Yes, you need to memorize it. Times, yeah, times again here. Times temperature change. What is the temperature we are dealing with now? They told us that the hot water is at the temperature of 90 degrees Celsius. So we write 90 degrees Celsius here. Okay? That is the temperature of the hot water, the higher temperature. Minus the temperature of the mixture. That is the one we did not know. So we put it to be theta. Put it in bracket. Put it to be theta. Put our equals to here. Come to this side. We meet mass of cold water. What is the value of the mass of cold water given to us? 100 grams. I say we are not changing it to kilograms, so we use it like that. So I substitute 100 grams here. 100 grams for the mass of the cold water. We are now on the side of cold water. We are finished with the side of hot water. We are on the side of cold water. Okay. Put times here. That stands here. C stands for specific capacity of water. And it's still the same water. So the value of the specific capacity will be the same thing. So I still write 4200 here. So times 4200. I spell that time first. Okay, times. Okay. Finally is the theta. What is the temperature of the cold water? The temperature of the cold water they gave us is 30 degrees Celsius. But just know this, that after the mixture, the temperature, that is the resulting temperature, will be lower than 90 degrees Celsius, but higher than 30 degrees Celsius. That is why we say 90 minus that resulting temperature, because it is lower than 90. But in this side, it will be that resulting temperature, because it will be higher than 30. We will now subtract 30. That will make me to write something like this. If I put bracket, like I did here, I will say that resulting temperature of the mixture, which I put here as theta, will be this theta, minus 30 degrees Celsius. Minus 30 degrees Celsius. You understand the gist? Here I subtracted this temperature from 90, because after mixture, for sure, the temperature will be less than 90. But here I subtracted 30 from the temperature, because after mixture, the temperature will be more than 30. That is what I want you to observe, so that next time you'll be solving mixture of whatever liquid or whatever solid or anything of higher temperature and lower temperature. Know that the higher temperature will subtract the mixture temperature, resulting temperature, while the resulting temperature will subtract the one of the lower temperature. That is the rule. That is how to solve it and get it correct. Okay, we continue. As we continue, I look at this side to make it easier, to make it more simple. I see 4200. See 4200 this side also. So I cancel it out, because they are the specific capacity of water, and here is water, so I cancel it out. So what remains here is 290 minus theta is equals to 100 theta minus 30. Let's evaluate. What do? We open the bracket. Open this bracket. So how do I do it? I'll use this 200 to multiply everything inside this bracket. So let me write it out. Open bracket. Open bracket. I will say 200 times 90. I'm opening this bracket now, and it will give me 18,000. I'll write it. 18,000, 0, 0, 0. Put this a minus here, and I'll say again 200 times theta will give me 200 theta. I'll write it. 200 theta. I'm done with this side. I come to this side, put this equals to. I'll say, I'll open this bracket just like I did here. I also do here. Let me write it also. Open bracket. Okay, I'll start. I will say 100 times theta will give me 100 theta. So I'll write it. 100 theta. Put this minus. And I will say again. 100 times 30, it will give me 3,000. I will write it. 3,000. I hope you are following. What do I do now? I collect like terms. How do I collect the like terms? I will join this one to this. Then this one that has theta, I join two of them together. That will make me to write something like this. I'll start now. Collecting like terms. Let me write it also. Collect like terms. Collect like terms. Okay? So I'll write this one first. I'll write 18,000. Carry this 3,000. Come and meet 18,000. Here in this side, it is minus. But if it cross this equality sign, come to this side, it becomes plus. So it will be 18,000 plus 3,000. Hope you understand. Put this equals to what? I come to this side. I write this one first. 100 theta. I want to join this 100 theta with this 200 theta. So I'll carry this 200 theta. Come and meet here, 100 theta here. Here it is minus. If it crosses this equality sign, come here, it becomes plus. So it will be 100 theta plus 200 theta. 200 theta. Is that clear? Final, what will give me? Add the two of them together, it will give me 18 plus 3 will give me 21. So 18,000 plus 3,000 is 21,000. I'll write it down. 21,000. Put this equals to 100 plus 200 gives 300. So 100 theta plus 200 theta will give us 300 theta plus 300 theta. Yes. I hope you understand to this level. Okay, let's continue. Now, because we are solving to get the value of theta, which represent the resulting temperature of this hot water and the cold water when they are mixed together, because we are solving to find its value, I'll make this theta now the subject of the formula, which will make me to write something like this. I will write theta, this theta. Theta, okay? Put this equals to what? I will write this number first. 21,000. 21,000 divided by what? The number with theta now will come down. It will be divided by this 300. 300. Which will give equals to what? Let's evaluate it first. Let's evaluate it. We evaluate it. So we say 21,000 divided by 300 is equals to 70. Okay? So we have theta. This theta now is equals to 70 degrees Celsius. Temperature is measured in degrees Celsius. So the resulting temperature when this 200 gram of water at 90 degrees Celsius and the 100 gram of water at 30 degrees Celsius were mixed together is 70 degrees Celsius. Yes. When the two of them were mixed together, the temperature of the mixture is 70 degrees Celsius. So assuming that the person that did this, assuming that the person wanted to bet, maybe he's betting water, want to bet warm water, which means the warm water that the person used to bet
was at
70 degrees Celsius. Yes. This one is not a warm water. The person did not bet with warm water. He bet with hot water. But that's, by the way, the main thing is that we have gotten the temperature of the mixture as 70 degrees Celsius. I hope you understand.